Okay, welcome back to the classroom. And now I promised you I would do this. I'm going to do the video on the experiment we did in class over the last couple of days. And the experiment we're doing is to determine which will actually boil faster. Okay, we're going to have one beaker that's going to be filled just with tap water, 200 milliliters, and a second beaker that's going to be filled with 200 milliliters of water plus 10 milliliters or 10 grams, same thing, of table salt. Now, I'm going to put it in after I put the 200 of water in. Whoop, overfilled it a little bit. There you go. Simply because that way I can be a little more accurate about how much water it is in it. And then we're just going to mix this around a little bit. Okay. Now that we've got that nice mixed, almost a solution, let's get our first temperature here between the two of them. Now, the water came straight out of the tap, so it should be a little cooler than the air around us. From what I can see here, salt water, which is this one, has a temperature right now of 20 degrees Celsius, and the water, just the plain tap water, is sitting at 21 degrees Celsius. So I'm going to turn on the hot plate to maximum temperature, check the time. So for the next little while, we're going to look at these two heat up. Yeah, it's going to be as exciting as watching water boil. We're going to watch the two of them heat up and see how fast they warm up towards a boiling point and see which one actually reaches the boiling point first. Okay? So right now we're at 25 seconds, and at 30 seconds, even though it's just beginning to warm up, we can already see a slight warming up on the salt side. We're at 21 degrees Celsius, 23 degrees Celsius on the side of the tap water. Now, for now, I'm going to leave them down straight, but what we really should be doing to measure the temperature is to leverage them up a little bit like this, so that we're not getting the heat directly off the glass that's coming off the hot plate itself. All right, coming up to the first minute, which is right now, and we see that the temperature in the salt side has gone up to 22 degrees Celsius, 28 degrees Celsius for the non-salt side. You might hear some sizzling going on. That's because the bottoms of the beakers were both a little wet before I put them on the hot plate itself, and that water is evaporating right now. It's bubbling underneath the actual beakers. Okay, 25 seconds in, coming up to the first minute and a half mark. And at a minute 30, the temperature of the salt water is sitting at 28 degrees Celsius. The temperature of the non-salt water, the straight tap water, is sitting at 30 degrees Celsius. So a couple of degrees difference. We're 10 seconds away from the 2-minute mark. In class, this is taken on average between 7.5 and 8 minutes to reach full boil. At the 2-minute mark, salt is at 31 degrees Celsius. Straight up tap water, 32. So they're beginning to come a little closer together. Once again, what we're really trying to find out is when, or to determine, is which one is actually going to come to a boiling point first. And we know the tap water will do that when we get to 100 degrees Celsius. Is there going to be a change with the salt water? Okay. At 2 minutes 30, which is now, salt water, 32 degrees Celsius. We're almost at the 40 degree mark with the tap water, about 38, 39 degrees Celsius. Now, this burner is certainly more quick. And it gets hotter than the one that we were using in class, the student burners. And that's as a safety precaution, but at least this one will take us a little quicker. Okay. Coming up on the 3-minute mark, at 3 minutes, we're just about reaching 40 degrees Celsius on the salt water, and we're just above 40 degrees Celsius on the tap water, maybe about 41. Keep in mind, you should know these numbers when we're moving on, marking them down as data so that you can use them when you're putting together your line graph to give you an actual heating curve to determine how they work. At 330, we're at 48 degrees Celsius on the salt side. On the non-salt side, about 48 degrees as well. Now, if you remember back to when we were working with the particle theory, you got to think about what's happening in these beakers right now and how much the particles are beginning to be moved around and beginning to make a difference. We may even see an expansion with the amount of water that may be in there, at least its volume. On the salt side, we're now up to 50 degrees Celsius. That's 4 minutes in. And on the non-salt side, on the freshwater side, we're at 52 degrees Celsius. One of the things I've asked the class to do is think about the various variables that we're taking into consideration here. And the only real variable that we should have is that one of these two solutions contains salt. But there could be other variables too. We'll go over them in a second. At 4 minutes 30 seconds, we're at 56 degrees Celsius on the salt side. On the tap water side, we've actually got up to 59. Some of the things that could affect this, I mean, if you think about it, the uncontrolled variables, what happens if one thermometer is more accurate than the other one? Okay, we're looking at red alcohol moving up inside of a tube. What happens if one is not as good as the other one? Okay, I guess this is 5 minutes now, maybe 6. Next 30, we're at 62 degrees Celsius on the salt side, and on the non-salt side, or even more than that, we're at about 66. It's rising quickly on this side too. Other variables too could be just how the burner works. If the burner is more efficient on this side than it is on that side, if it develops more heat on one side or the other, I mean, we don't know for sure, but if it does, it's going to have an effect on how fast they warm up. Next 30 seconds in, 72 degrees Celsius on the salt side. On the non-salt side, we're at about 73. So again, they're evening out a little bit. Can you think of any other variables that might affect this? I mean, there's no real airflow in the classroom that's going to change what's going on. Maybe the cleanliness of the beakers could come into consideration, who knows? But the really big one, the manipulated variable we've got is the 10 milligrams or 10 milliliters of salt that are inside. Okay, next 30 seconds has passed. We're at 79 degrees Celsius on the salt side. And if we look on the other side, right now on the non-salt side, 81 degrees Celsius for the tap water. Now you might be able to hear a little bit of sound. That's coming out of the tap water side. That's the beginning of boiling. It's not actually boiling, but the water that is sitting right up against the glass that's right up against the heat is beginning to react. Not all the other water, all the other particles are reaching that temperature. Salt, 88 degrees Celsius. Non-salt, 89 degrees Celsius. So the water particles that are up right against the glass, because they're getting the most heat right now, are beginning to react as if they're boiling. But the rest of the water is at a temperature that is well below the boiling point. So you get a little bit of the sound, but you really don't have that vigorous, almost violent boiling we need to have in order to say that we're at the boiling point. Next measurement, salt, 94 degrees Celsius. Tap water, 95 degrees Celsius. We're getting close. Once we get to 100 degrees Celsius, we're officially at the boiling point on this side. Will it be different, though, on the salt side? It's a good question. Now, if you look at it, both of them are beginning to get to the boiling point. Which one's boiled first? That's a good question. I'm going to have to take a quick look at what goes on in that video later on. Next mark. Now, on the salt side, we're at 103 degrees Celsius. Going on to 104. On the non-salt side, we're at 100 because after all, we're boiling now. So the question is, which one boiled first, and why does having salt in it make a difference? Look at the two of them boil. Which one is boiling more violently? Which one started boiling first? And think about the actual test we're about to do, the actual work you've been doing. In the lab, one of the questions that's asked is, would there be a difference in the reaction and in the length of time this took if instead of 10 milliliters of salt, we added 20? Okay? So there's the data you need. There's the information you need. The rest of the is up to you.